Okay, guys, so today we're going to stay in section 8.2. We're still working on finding the perimeter of composite figures, which, remember, is basically two or more figures that are put together. So I want to give you a couple of more complex examples so you guys are ready for the classwork. All right, so our first composite figure is going to be a combination of a triangle and a semicircle. So, all right. So here you can see this is sort of the triangular part. All right. This dashed line is showing sort of where the line would be if this was just a triangle. And then we have our half circle, our semicircle part. Okay, so we need to find the perimeter, which would be a measure of all of the way around these sides, right? So in this case, this bottom triangular piece is going to be 6 feet. This piece, which is like the height of the triangle, will be 8 feet. All right, and then this cross dashed segment, which is not actually part of the outside of the figure, but we need it, is 10 feet. Okay. Now, we need that piece because if this was a full circle that went all the way around like this, that 10 feet would be our diameter, right? And if you recall, basically to find the diameter of a the circumference of a semicircle, we find the circumference as if it was a full circle and then divide it by 2. So in this case, we're going to do C equals pi times the diameter. All right, so C equals 3.14 times 10. All right, you guys could enter that into your calculator. All right, but basically your C equals 31.4. We take that and we divide it by 2. All right, and you end up with 15.7. Okay, so that's the distance around this semicircle part for the diameter. And then all we have to do is add 6 and 8 to that. All right, so 15.7 plus 6 plus 8. All right, and we end up with a perimeter of 29.7 feet. All right, I'll put it here as well. So you have to recognize what two types of shapes you have smushed together. So here we had a triangle. We don't really have to do anything special. We just had to add our 6 and our 8 together. But here we had to do some calculations to figure out the semicircle, right? We did our circumference formula. We divided by 2 because it's only half of a circle, right? And we got 15.7. We added that for our 6 and our 8, and we got 29.7 feet. Okay. Let's do one more example. This one on the surface might seem a little trickier, but it's actually going to be easier. So let's say we have a track, like the high school track. It's sort of an oval shape. All right. It's my rough high school track. Or how about we do it this way? All right, so there's the curve. I'm going to put a dashed line. Okay. Here are the straights. another dashed line, and here's the other curve. All right, now let's say these straights are 100 meters, right? And that's how it is in real life. A straightaway is 100 meters. All right, but from the middle here to the outside, that is 32 meters. And they want us to find their perimeter all the way around this track. Okay. Now, they gave us the radius for this semicircle, and this is like 2 semicircles, right? But here's the thing. We don't need to divide our circumference by 2 because we're not working with just one semicircle to find the perimeter. We're working with 2 and they're the same. So together they would make a full circle, right? So we could just do our normal C equals 2 pi r formula, okay? So if we plug in, we'll get C equals 2 times pi times 32, correct? If we do that, we're going to end up with, I'm going to round it to C equals 201, okay, meters. So really, this would be 100.5 meters around. And so with this, right? But I'm not going to divide it by 2 to figure that out just because there's 2 semicircles together that make a full circle. So this and this together make 201. Then I have to add this side and this side. So I'm going to do 201 plus 100 plus 100, and you're going to get 401 meters for the perimeter, okay? And that's the measure going all the way around, right? If you actually run one lap around the track, you're doing 400 meters, but because we're on the actually measuring the very outside of the track, it comes to 401. All right, so sometimes you have to look and think, okay, yeah, there's semicircles here, but there's 2 of them. They're identical, so together they make a full circle. So I don't have to divide my circumference by 2. I just calculate the circumference. All right, guys, hopefully that gives you a little insight, and use this to help you get through the classwork questions on big ideas. All right,